Ugh, it's cold. Why does a cup of tea cool down? Can't it just stay the same temperature forever? I know that sounds like a silly question, but minimizing heat loss is a really important topic in the field of thermodynamics. If you look closely at objects down to the molecular level, we'll see that the particles move around a lot. Temperature is defined as the average movement or kinetic energy of the particles in that substance. Now, things don't stay the same temperature forever. That'd be boring. If you place a hot object next to a cold object, you'll get a net flow of heat from hot to cold over time. And there's three main methods in which this can happen. When neighboring particles bump into each other and transfer their kinetic energy, it's called conduction, which typically happens in solids because the particles there are fixed in place. One way I can prevent heat loss through conduction in my cup is by placing it on a poor conductor, such as this styrofoam. When particles themselves move through a substance to transfer heat, it's called convection, and this can only occur in fluids because there the particles are free to move. Hot fluid rises because the particles move faster, spread out, and reduce its density, and cold fluid sinks down to replace it, which circulates heat through the fluid. I can prevent heat loss through convection around my cup by trapping the air, which is a fluid, around it. When electromagnetic waves carry energy, it's called radiation. And the sun's radiation actually reaches us through the vacuum of space, so it doesn't require a medium at all. Electromagnetic radiation is given off when electrons transition from high energy states to low energy states. Infrared is typically the range we call heat, but other frequencies can heat up objects too. By reflecting radiation back into my mug using a shiny silver surface, I can greatly limit heat loss by radiation. The use of insulation, trapping air, and reflective silver surfaces are actually pretty common ways to reduce heat loss. In fact, a thermos uses all three of these methods. So the next time your cup of tea cools down, you know that the heat transfer trio are to blame.